Hello friends, I am Dr. Marathe from Department of Metallurgy. Today I will discuss about the concept of fermentation, which is related to the bacterial metabolism. So what is meant by fermentation? Now the scientific meaning of fermentation, or the proper definition of scientific fermentation, is what? It is an anaerobic process in which organic compound acts as electron donor as well as electron acceptor. Now this is the proper definition of fermentation, word fermentation. What is that? I will repeat it again. It is an anaerobic process. Obviously, it is an anaerobic process which is carried out in absence of oxygen, in which organic compound acts as electron donor as well as electron acceptor. Now I will try to illustrate, I will try to explain this concept, how the organic compound acts as electron donor as well as electron acceptor. Now for this, you have to understand the glycolysis or EMP pathway, where there is only one reaction in which oxidation occurs. In my first video, I have already explained about the glycolysis with structure, whatever the changes that occur during the glycolysis, enzymes involved in the glycolysis, everything in a simplified language I have explained with structure. Okay, so today I will only mention the reaction which is related to the fermentation technology, or to understand this concept, how the organic compounds act as electron donor as well as electron acceptor. Okay, so there are 10 reactions of glycolysis. One, it starts from glucose. Okay, in the first reaction, this glucose, it is phosphorylated to glucose 6-phosphate. Thus, glucose 6-phosphate, it is isomerized to fructose 6-phosphate. Now this fructose 6-phosphate, it is again phosphorylated to fructose 1,6-diphosphate. Fructose 1,6-biphosphate. Okay. Now this is the ring structure. The splitting of this ring occurs in the next reaction by the enzyme aldolase, and it produces 2 3-carbon structures. These are known as DHAP, is known as dihydroxyacetone phosphate. Second is G3P, glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. Now this glyceraldehyde 3-phosphate, especially I will draw the structure of this glyceraldehyde 3-phosphate. This is what C double bond O H H C O H and CH2OP. CH2OP. This is glyceraldehyde 3-phosphate. Now this glyceraldehyde 3-phosphate, in the next reaction, subsequent reaction, oxidation of this glyceraldehyde 3-phosphate occurs. During the reaction, NAD plus, which is oxidized NAD, now it removes 2 hydrogen atoms and it becomes NADH plus H plus. Okay, obviously every components after the splitting of fructose 1,6-biphosphate. There is a formation of DHAP and G3P. Whatever the DHAP is formed, it is further converted into G3P. So from this, every compound is what? Twice. Okay. So this G3P, it is converted into 1,3-biphosphoglycerate. And draw the structure of this 1,3-biphosphoglycerate. That is C double bond O P H C OH CH2O P. Now there are two phosphate groups, high energy phosphate groups. Both are not high energy, but one which is linked to the carbon number 1, it is phosphate group, high energy phosphate group, and there is another phosphate group attached to the carbon number 3. So this is what 1,3-biphosphate. During the reaction, whatever the enzyme works, that is known as glyceraldehyde 3-phosphate dehydrogenase, G3P dehydrogenase. Obviously, the name of the enzyme indicates that during the process, during the conversion, dehydrogenation reaction occurs, and then whatever the hydrogens are removed, electrons are removed, these are accepted by NAD, gets reduced to NADH plus result, and simultaneously there is an addition of one inorganic PI. Okay. Now this is the only oxidation reaction in glycolysis. Then 1,3-biphosphoglycerate is converted to 3-phosphoglycerate. 3-phosphoglycerate converted to 2-phosphoglycerate. 2-phosphoglycerate into phosphoenol pyruvate. Phosphoenol pyruvate. Okay, and the last product formed from the phosphoenol pyruvate is pyruvic acid. This is what? Pyruvic acid. CH3 C double bond O COOH. This is known as pyruvate. This is known as pyruvate after PEP by the enzyme pyruvate kinase. Okay. Now, what is the fate of this pyruvic acid? What happens after the formation of pyruvic acid? What is the next path for pyruvic acid? Okay. It depends on presence and absence of oxygen. It depends on presence and absence of oxygen. If oxygen, because this glycolysis, it is operated aerobically as well as anaerobically. Means glycolysis, it can occur in presence of oxygen as well as in absence of oxygen. But the fate of pyruvic acid, it depends on presence and absence of oxygen. If oxygen is present, then it enters into the respiration pathway. Means it enters into the TCA cycle that I will explain in my next video. Okay, but if oxygen is not available, means under anaerobic condition, this pyruvate, it is converted into lactate. It is converted into lactate, lactic acid. Okay, so in absence of oxygen, pyruvate enters into the fermentation pathway. Okay, as there is no availability of oxygen, that's why it enters into the fermentation pathway. This is carried out by the enzyme known as LDH. What is the long form of LDH? Lactate dehydrogenase. Okay, so during reaction, NADH plus H plus, it is oxidized to NAD plus. Obviously, there is a reduction of pyruvate into lactate, and for reduction purpose, it will require a reducing agent, and that reducing agent is what? NADH plus H plus. Okay, that donates the electron to pyruvate and it gets reduced to lactate. So these two atoms are reduced by the pyruvate and that becomes what? Lactate. Now try to understand whatever the definition we have seen in the introductory part. That is what is fermentation? fermentation, it is an anaerobic process. Obviously, it occurs in absence of oxygen. That's why it is an anaerobic process in which organic compound acts as an electron donor as well as electron acceptor. Okay. So, whatever during the oxidation process, during the oxidation of this glyceraldehyde 3-phosphate into 1,3-biphosphoglycerate, during this process, oxidation occurs. Whatever the NADH plus H plus it has been formed, that NADH plus H plus it can be used in the last reaction where the pyruvic acid enters into the fermentation pathway and it is converted to lactate. It is converted to lactate. So during this reaction, whatever the NADH plus H plus is formed, it donates the electron in this reaction, itself gets oxidized and it reduces the pyruvate to lactate. Now the definition is what? In which organic compounds acts as an electron donor as well as electron acceptor. Here glyceraldehyde 3-phosphate is electron donor, NAD is what? Electron acceptor. Both are organic compound. In the same case, NADH plus H plus is the organic compound, electron donor, and who is the receiver? Pyruvate, which is also organic compound. So it gets reduced to lactose. So in both cases, electron donor and electron acceptor both are organic compounds. This is the meaning of definition of fermentation. Okay. So during our next lecture, we'll try to understand what is meant by respiration. I hope you must have understood this concept. Thank you.